Today I'm going to talk about how can you provide a value with machine learning, and there's a small team, the organization, and our insights in the process. And yes, we do update models hundreds of times a day. We will learn about it later. So first of all, I'm a engineer at Funcorp. I'm getting paid to recommend memes, basically. For that, I write code, Python, Rust, whatever it takes. Basically, I just make models go into production, and that's it. Now, a bit more about Funcorp. Our flagship app is iFunny. It is some kind of mix of TikTok and Reddit in terms of UI. We basically show memes to the people, they react to them, and our main task is to reorder the memes so the user stays in the application longer. A bit more numbers about the company. We have more than 10 million monthly active users in the United States. We've been in business since 2004, and there are 10 or more right now apps targeted on different audiences and regions written and deployed by us. We use ML in lots of cases, from auto moderation to fraud detection to text recognition, and also push recommendations, feed recommendations. Today we're going to focus on the last two use cases. So what challenges did we have? And I think a lot of people have with machine learning and deploying it into production. First of all is quality assurance, or how do we make sure that we bring value to our organization, and after we ensure that the problem of stability comes to mind, or how can we make sure that we are still bringing value to the people, or our users, or the business itself. When we kind of figure out those two, we are trying to reduce time to market, because business wants everything deployed yesterday, and that's a common issue that models are stuck into research notebooks. We have to get feedback from users as soon as possible. And I think the fourth challenge is fear of missing out, because there are a lot of platforms, frameworks, tools, and startups right now. It's sometimes hard to choose, and we fall into some kind of barrage of choosing the right things to do our job. And common solution to those challenges, a lot of times, would be build some new framework or internal tool which should solve all our problems. But in our engineering culture, we don't believe in this approach, and we have some different ideas in mind about building stable machine learning models, and today I would like to share with you our insights. And our approach would be to use the most common software engineering tools, because most of the challenges mentioned on the previous slide are just software engineering challenges, and we should just pick the right pragmatic tools to solve them. So about our team, there are 3 more software engineers except me. There are 5 data scientists doing all kinds of work. 1 business analytic for A/B testing and managing all this ClickHouse, the data warehouse storage, and 1 DevOps engineer, although he works with us kind of part-time because we do not have this many problems with the infrastructure right now. So talking about infrastructure, in our case, it is a hybrid cloud approach with Kubernetes cluster being the heart of it. Some nodes rely in AWS, some of them in our rack in a data center in the United States. Airflow is deployed inside this Kubernetes cluster. Our tools like services, message brokers, databases are spread across AWS and our rack as well, but they lie outside of the cluster for some DevOps reasons. Training overview, just so you know what I'm talking about, is quite simple, and I don't think it's worth mentioning all those arrows and stuff like that here. The only interesting thing you might see that we have continuous deployment pipeline in the Airflow, where the last thing for every model is deploying it into production. So the model never lies into S3 just for future storage. It is always deployed in the production after a successful training pipeline. Now let's talk why do we need such frequent model updates in the field, or the domain of memes is quite fragile, or it updates very quickly, so we should be able to adapt to those changes very fast. For example, then this meme situation on Oscars happened. There were a lot of memes about it, and the model should pick up trends very quickly and forget about the stuff that happened before quickly as well. For that, we update models mostly once an hour. By those models, I mean NFM, ILS, those kind of candidate selection models for recommendation systems. All the updates happen through HTTP API in the feed service you see on the screen. The service itself is written in Kotlin, but we'll talk about it in the stability part. So that's kind of it about the context. Let's return to the problems itself. And first thing we should tackle is quality assurance. In my eyes, at least, I think those of you who come from software engineering saw this picture a lot. It's basically the scheme how we write and test software, and in the part about quality assurance, we will go from the bottom to the highest point in this pyramid, which is A/B testing in our case, not acceptance testing. So let's start. First thing first, unit testing doesn't differ much from average software engineering. I just wanted to mention Kotlin Spark API, which is a wonderful library written and deployed by JetBrains. It provides you with all the needed interfaces and syntax sugar to write Spark applications in Kotlin. For example, on the slide you might see how simple it is to write a unit test for our code. The next thing would be integration testing, and there are a lot of problems with it, and a lot of bugs caused by in the production. For example, object ID might not serialize as it should from a Spark new connection drive or something like that. So to tackle those problems, we use local stack to mock S3 and other AWS services, test containers to be able to run all those things into continuous environment or into continuous integration pipelines, and standalone or Minikube clusters of Spark to check that the applications might be deployed correctly. The system testing is like the hardest thing about all of it, and it is very important to check that all the components that were deployed work together correctly. And in case of machine learning, it is especially hard when you have a lot of configuration files. Staging has much less data than production, and all those challenges we are trying to solve by having the second instance of Airflow to check all the configurations that is needed to run the tasks. Staging for every service and database that is used and that you see on the slide. There is a separate environment you can deploy with one click of a button. And dry runs mean that sometimes we run all the pipeline except the data in the model or the data in the database just to check that current pipeline is able to handle production load. And A/B testing is probably, in my opinion, the most important part of deploying any machine learning to users. And if you're looking into something you should focus on first in your team, I would suggest it be A/B testing, because it is the only kind of test which allows you to get real feedback from users and to see how they react to your model deployment or update or any change in the data that happened during the time of the test. For this reason, we have internal A/B test service which allows us to slice users into multiple categories, from their age on the platform to the platform they're using to access the app, to the version of their OS, and multiple different kinds of slices there. There are also generations of A/B tests. For example, if we damaged a single group of users with bad recommendations for a month, we can just regenerate the groups itself and get the uniform distribution or the same distribution and all the control and test groups once again. So all our decisions are based on this A/B testing. Oh, you're able to see the meme here. And by that I was trying to show that every decision about the model is based on the tests that are being run on the platform. There are multiple of them at the same time, and that concludes part about quality assurance. The most important thing there was that once you want to deploy machine learning, I would really encourage you to see if you are able to measure the impact of algorithms that are being deployed. Now let's get into stability part of the conversation. By stability, I mean operation workloads like monitoring, deploying stuff, making sure that you know what code produced, what artifacts, and everything like this. As I mentioned, Airflow for us was deployed in the Kubernetes cluster. After that, we wrote continuous deployment pipeline for it, because the only thing we update basically is our custom Python provider with a code which helps data science team to access the other services in the infrastructure, and everything was quite easy to automate. So here's the result of the thing. Basically, you can update the provider, put a tag on the Git repository, and then it will deploy Airflow automatically. With the Spark jobs, it was quite a bit harder to manage all the Python, Java, and other dependencies, but in the field it works like this. For every new feature, we basically build the artifact, update the version of it in the Airflow. It might be stable or the testing one, run the pipeline. In the case of Airflow, it's done with a custom Spark provider, which fixes some minor issues that are caused by deploying into Kubernetes. For example, it cannot detect the pod name properly if it was templated. And it's the pipeline of our features deployment, I would say. And the monitoring of models is quite an interesting and challenging task. I would split it into 4 different areas. We have data updates for every feature is updated by default in every 5 minutes, because we are trying to adapt to the changes in user behavior as frequently as possible. And for that, we need to be able to see those changes very fast in the models itself. Model updates mean that if we update models once an hour, we should be able to check if the model was really updated in the service, because not sometimes, all the model go through the event sourcing kind of pipeline. The service writes change in the Mongo database and then reads the state it should be in. So all the instances are synced all the time. Data quality monitoring is a very broad topic, and for every test or every new feature being deployed, we should consider that. So it is why it's here. And model validation, I will just talk about it later. So for monitoring model updates and Airflow workloads in general, we have used the stack. It is quite a complicated stack of technologies on the slide for just being able to detect that something went wrong in the Airflow, but everything except the Airflow was provided to us by the DevOps team already. So it was a no-brainer decision for us to just use the tools we already have on site to monitor Airflow. There is an interesting concept in it called SLA. I encourage you to read about it if you have not. It allows you to provide some kind of guarantee between the Airflow and other services, which will check if the task was deployed or if the task succeeded in the time you expect it to succeed. For data quality monitoring, we have discovered or checked a lot of tooling out there and a lot of different platforms or frameworks which allow one to do it, but went with just custom code in the Airflow providers, which checks the collections that were deployed or which were changed the last 30 minutes, and then writes metrics into Grafana, all statsd, and then they go to Grafana, and we are able to see them on the standard dashboards along with all the services. it is just an example of things being ran in the Airflow, and then we have discussed 3 or 4 things, and the last one brings us to model validation. It is completely controlled by the data science team, and the reason for that is that we believe that autonomy is key for decreasing time to market. So we are trying to, as an MLOps team or as a software engineering unit, we are trying to provide all the tools needed for data scientists to do their job quicker and unblock them everywhere where it's possible. Model validation is one of those areas. So since we are trying to provide deploy models quicker, let's get to the time to market part of the conversation. And for this, I should bring up the inference one more time to discuss how do we unblock the model deployment. For the data science team to be able to just run the task or upload the new model into the feed service, we need 2 things. First of all, we need to make sure that the environment supports this model. And for us, Onyx did that because we are able to convert any model there is into the Onyx, and it is done by the data science team. They know the op version and the Onyx version, and they're able to just write custom code to do it. And the second one is dynamic uploading or downloading of features, and we will discuss it right at the end of the talk. For the model updates, there is a simple HTTP API, and every model update just have a S3 path to the model, parameters like A/B test or something like this, and everything basically works. We are able to delete or get the models as well. And unblocking feature engineering. What we expected as software engineers will then encounter this problem, but we will be able to write a single Spark or a single framework based on Spark, which will handle all the online and offline data. It will be very handy for data science team to use, and we will be able to reduce time to market significantly with it. And then reality hit us, and we learned that data science team do not want to learn Kotlin to write code for some reason. I don't know why. Airflow, we prefer using Airflow operators or custom ClickHouse code for basically everything. We do not need Spark or S3. We just want to read it from the ClickHouse and write it to the Mongo database. And since we are not trying to write the best feature framework out there, we are trying to deliver value for our business. We let data science team to read it and basically allow them everything they can imagine doing with the data, with one condition: we should be able to monitor it. So it is written in Mongo database, and we should have some kind of monitoring written on top of it in the Airflow as well, to see if the feature works and it is updated, and it was updated when needed. So that brings us close to the conclusion. Common solutions are very, very hard. And if you're trying to deploy feature store or feature framework or anything that somehow restricts data scientists in doing their stuff, we will come to the limit, and very soon we would like to cross the limit and ask you for something which is not supported by your tool. And let's talk about feature store once again. As you might see, for us, we just have 2 different data sources. For online, it is Mongo database, which is cached, or all the features there are cached in Memcache and then in the service itself. And on the training side, we have a ClickHouse and S3 for in the complete freedom of data scientists. The reason for that, as I said, is reducing time to market. And in our research of different technologies helping to unify this process, we came to the conclusion that for us, it wasn't possible to limit ourselves to any technology. It is important to be able to deploy different features which vary one of each other significantly, and what we would like to write a lot of building blocks and then complete them in our kind of feature store, which will allow our business to succeed and our features to be there in time, be monitored well. So the one thing I would like for you to bring home after this talk is deliver first and abstract later. So in the machine learning space, they are all tempted to write this one thing that will help us all, or to find this silver bullet. And in Funcorp, we don't believe in this kind of approach. We're trying to deliver value now and then see how we can deliver it even better. Thank you for your attention. Here are my contacts on the slide.
Thank you. Time for questions. Please.
So I guess for me, also testing and monitoring sounds more like release engineering rather than like quality assurance. And platforms like Kubeflow or like Vertex or something SageMaker on AWS, they usually provide you with all this release engineering capabilities where you, I don't know, make degree deployments, split traffic, whatever. And from your setup, it sounds like you reinvented a lot of that.
I cannot agree with that because we have tried SageMaker and the parts of it and have seen or explored how it would work in our use case, and sometimes it just doesn't support all the features we need, and it's the deal breaker for us. And for example, feed service that was on this slide, it supports custom pipelines of models. For example, there are right now, I guess, 20 of them in the service, and we are able to combine them in different fashion. And it would not be possible to implement that in any provided solution because, for example, for a single model inference, there's 10K of content IDs with all the features, and there is a really smart way of caching them and going to other services, which is just not possible in providing solutions. So yes, there are solutions which might solve those problems. We have investigated them, but it just wasn't for us.
So two questions. First one, you specifically mentioned that the Airflow is located in your data center, not in the cloud. Is there any thought behind that, like reasons?
Actually, I know the node, it is deployed at, but I do not know if it is in AWS or in our data center. It was shown in the diagram like it is in the rack, but I'm not sure about it, to be honest.
Because like overall it shouldn't be much different. There shouldn't be much difference.
Yeah, there's no difference between things deployed in AWS or data center, except like minor lags in the networking in some libraries.
And the second question, you talked about the model stability and data quality as well. Are they implemented in the pipeline as steps in the graph, or they are inside, for example, the training stack or somewhere else?
Yes, tasks in the Airflow graphs. There are separated graphs for the monitoring. If you are not able to include them in the data pipeline or the model training pipeline, or so there are two places to place those tasks in the model training pipeline, or there is a separate deck for just for monitoring, basically.
And you do it as a separate step in the graph, or?
Yes. Or everything you can write into the stats.d will get into the dashboards later, so it basically doesn't matter where you play this code.
And if you don't mind, can you say a couple of more words about the stats.d, because
it is the proxy between services and Prometheus, basically. So it is the component you deploy near your application. There you push all the metrics, and it then pushes it into Prometheus or the database underlying.
Some more general thing, why do you even have like private data center? Why do you just don't use the cloud? Do you have some private data which you can?
It's much cheaper.
Oh.
Yeah.
Good.
So we can conclude on this. Thank you for the presentation.
Thank you.